students, welcome to day 11 of PU2 Brahmastra Series, right? So today is Thursday and it's time for studying chemistry, and today we are going to do the last chapter of organic chemistry, like the main chapters if you consider, that is amines. Okay, so I'll be discussing the different, we'll be doing a revision and we'll be practicing a lot of questions from this chapter. So I can tell you, if you watch this one video for amines, then all your questions are done. You need not worry about anything. Okay, so please sit with your notebook and pen and then watch this complete video and make sure that you make the list of the questions and answers as well. Okay, so let's get started here. If you see, the weightage of this particular chapter is 9 marks. In that, BSA, like that is your very short answer questions, which can be either MCQ or fill in the blanks. You will be getting 2 questions from there, and then you will be getting one 5-marker question. Okay, sorry, the weightage here is 7. Okay, weightage is 7. Let me correct it here. Okay, I'll take white ink so that it is visible to all of you. Yeah, so it is 7. Okay, now coming to number of questions that we have discussed in this particular video is, we are going to take almost 10 MCQs, and all these MCQs are your HOTS questions, and in 5 markers we are going to discuss 20 questions. Okay, and in the last slide we'll be discussing the most important topics that you need to revise from this particular chapter. Okay, so now students, without further delay, let's get started. When you are watching the video, you can comment the answers. Okay, make sure that you are engaging with the class, you are commenting the answers, so that the class is really interesting. Okay, fine. First question here: decreasing order of basic nature in aqueous solution is. Okay, so in aqueous solution we have 2 orders, okay, that you should remember. In aqueous solution, for methyl group, okay, if our group is methyl group, we have the order 2 degree, 1 degree, 3 degree and ammonia. Okay, now if you consider R is ethyl group, okay, R is ethyl group, then we have 2 degree, 3 degree, 1 degree and ammonia. Okay, so this is the order. So definitely here we can see 2 degree has to come in the first. So you can see here first option is 2 degree, right? So that is why correct answer for this question will be option number C. 2, 1, then we have ammonia, and then we have C6H5NH2. Okay. Next, coming to question number 2, identify the product in the following reaction. So C6H5NH2 with ACTO. Okay, so this one will give you what? This is acylation. Okay, so if you have this one NH2 and you are treating with AC2O, so I can write it like this: CH3CO whole 2O. Okay, so if you are treating this one, we get first is the acylation takes place, that is NHCO CH3. Okay, now if you treat it with bromine CCl2, okay, bromine CCl4 actually, so what will happen? Bromination will take place, but it will take place only at the para position. Okay, so we will get here NHCO CH3 with bromine at para position. Next, H2O. If you take water, what will happen? This group NHCOCH3 group will be converted to NH2 group. Okay, so the correct answer for this question will be para-bromoaniline. Okay, option number A is the correct answer. Okay, next is question number 3. In the chemical reaction, the compound A and B respectively are. So when you do NaNO2HCl, okay, that is what diazotization. So NH2 group gets converted to N2 plus and Cl minus. Okay, and next when you treat it with H plus and BF4 minus, we get this one, that is F. Fluorobenzene is attached to that. Okay, fluorination takes place with this. So the first one will be benzene diazonium chloride, and then we will get fluorobenzene. So correct answer is option number D. Okay, next question number 4. N2 gas is liberated when HCl and Na2 react with the following compounds. So whenever you have aliphatic amines, okay, if you have aliphatic amines, okay, and you are reacting it with HNO2, then definitely you will get ROH plus N2 gas will be released, right? So whichever, so definitely these two are your aliphatic amines, so this one will give you. Even amides, okay, amides also react with this one, and ketones also react to give you nitrogen gas. So here the answer will be 1, 2, 3 and 4, that is option number C, okay. Next, question number 5, identify C in the following sequence of reaction. So you can see this one is azobenzene, okay, N plus, okay. Now what happens here, when you treat it with CuCN KCN, okay, CuCN KCN will convert this one to cyanide group, okay, you will get here cyanide group, you will get here CN group. Then if you treat it with LiAlH4, okay, if you treat it with LiAlH4, then we will get here CH2 NH2, okay. And then if you treat it with nitrous acid, this one will get converted to alcohol, so we will get benzyl alcohol, okay. Correct answer is option number C here. Next is question number 6. Nitration of aniline in strong acidic medium also gives meta-nitroaniline. So now you see, if you see, if you have taken NH2, okay, and you treat it with concentrated HNO3. So what happens, this is a Lewis base, this is an acid. So first what happens, we get here protonation of the anilium ion. This is formed, right? Once NH3 plus is formed, after that this becomes an electron withdrawing group, okay. Now for this electron withdrawing group, what will happen, we need meta-nitroaniline. So it will now direct the nitrogen group or NO2 group to the meta position, okay. So what happens, in acidic medium, aniline is present as anilium ion, okay. Correct answer is option number D here. Okay, next, the correct order of basic strength of methyl substituted amines in aqueous solution is. So I told you methyl substituted order is 2 degree, 1 degree and then 3 degree, right? So you can see the first one 2 degree here, this is 3 degree, this is 3 degree, we can eliminate. So correct answer is option number B, okay. 2, 1, 3. Okay, next, the reagent R in the given sequence of chemical reactions is, okay. So now what we are doing, first NaNO2 converted to N2 plus to Cl minus, and then you want R, means you are removing this N2 plus Cl minus with H group, okay, you have replaced with its H group. So for replacing with H group, we need ethyl alcohol, option number B is the correct answer. I will be discussing the reactions, at that time I will be telling you all these reactions again, okay. Next is question number 9, the product formed from the following sequence of reaction. First you have RCN and you are treating with LiAlH4. We all know LiAlH4 is a reducing agent, so it will convert this one to RCH2NH2, okay. So first we will get here CH2NH2, okay. Now with NaNO2HCl, what will happen, that is with nitrous acid, it will get converted to alcohol, okay, CH2OH, and then yeah, that will be the final product. Option number B will be the correct answer here, okay. Next is question number 10. Coupling of benzene diazonium chloride with phenol occurs in dash medium. Now see, with phenol, so phenol is a basic, phenol is acidic in nature, so the reaction must occur in basic medium, right? So that is why option number A is the correct answer. And with aniline, aniline itself is a base, so the reaction should occur in the acidic medium, okay. So that is option number A is the correct answer here, okay. Now we will move towards, before moving towards the long answer question, 5 marker questions, what I want to discuss is the methods of preparation, okay. We will quickly revise the methods of preparation. So here remember, we have total 6 methods of preparation. The first one is from nitro compounds, reduction of nitro compounds. Second one, ammonolysis of alkyl halides. Then reduction of nitriles, nitro compounds, ammonolysis, reduction of nitriles, then reduction of amides. You can see 3 reduction reactions are there. Then you have 2 name reactions, Gabriel phthalimide and Hoffman bromamide. I think all of you can remember. Let us revise. First is three reduction reactions you can easily remember, 2 name reactions and 1 is ammonolysis. So 3 reduction, first is reduction of nitro compounds, reduction of nitriles and reduction of amides. Clear? Then you have Gabriel phthalimide and Hoffman bromamide degradation. And lastly, the 6th one you can remember as ammonolysis of haloalkanes. Okay. Now we will see these methods of preparation. The first one was reduction of nitro compounds, right? So if you see here, this is first one, reduction of nitro compounds. What are the reagents you can use? You can use SnHCl. So I can just write down here nitro compounds. Okay, SnHCl or FeHCl, or you can use H2 palladium in ethanol. Okay, H2 palladium in presence of ethanol. This is done, nitro compounds. The second one is ammonolysis. Okay, now this is very important, ammonolysis. Okay, now in ammonolysis what happens, see carefully, first you take a haloalkane and you take ammonia. Okay, so from this NH3 and RX you get HX. Okay, you form HX. So now what is remaining? RNH2. Okay, so now similarly, so what happens exactly is, now this lone pair, okay, attacks on this carbon, on this R group. So we get a salt like this, RNH3 plus and X minus. Now when you treat it with NaOH, you get RNH2. Okay, but the reaction doesn't stop here. The RNH2 reacts with another molecule of RX. So again one of the H will be replaced with R. So we will get R2NH. Then again if you react with RX, we will get R3N. Again if you react with RX, we get R4N plus and X minus. Okay, ammonolysis. The third one is reduction of, first is reduction of nitro compounds, ammonolysis. The third one is reduction of amides, right? So we have reduction of amides here, reduction of amides. Okay, so if you see reduction of amides, you can use lithium aluminium hydride. Okay, very simple reagent, lithium aluminium hydride. If you get, you will get RNH2. Okay, so now here what happens, the number of carbons, so you will get RCH2NH2. Okay, RCH2NH2 you will get. The fourth one was reduction of nitriles. Okay, so for nitriles we have different type of reagent. One is your hydrogen nickel, then you have LiLH4, or you can have sodium amalgam and ethanol NaC2H5OH. Okay, you have hydrogen nickel, lithium aluminium hydride or NaC2H5OH. Okay, so that will give you nitriles. Next one is your Hoffman bromamide degradation. Okay, Hoffman bromamide degradation. Now here what happened, when you have RCONH2 and you treat it with bromine and NaOH. Okay, so in that case this CO group, okay, is removed and you get RNH2. Okay, so that means the number of carbons in the amide and the number of carbons in the amine is not same. One less carbon will be present. Okay, so now let us quickly revise through this one. See how I am revising you, I am doing active recall again and again so that you can memorize these 6 methods of preparation. So let us write down. For reduction of nitro compounds, what all reagents we can use? SnHCl or FeHCl, right? Or we can use H2 palladium, right? These 3 reagents are there, H2 palladium, SnHCl or FeHCl. For ammonolysis of alkyl halides, we have to just treat RX with ammonia. Okay. Next, reduction of nitriles means RCN. For that we can use either lithium aluminium hydride, okay, or we can use sodium amalgam in presence of ethyl alcohol, okay, or one more we can use is again H2 nickel. Okay, so you can see here H2 nickel, lithium aluminium hydride or NaC2H5OH. For reduction of amides, there is no tension, we have only one reagent, lithium aluminium hydride. For for Hoffman bromamide degradation, we need for For Hoffman bromamide degradation, we need Br2 in presence of NaOH. Okay, now we will see Gabriel phthalimide synthesis. Okay, this is one major question that is being asked from this chapter. Okay, so first of all, we consider here, we take this compound is called as phthalimide. Okay, we take this compound as the reactant phthalimide. Then you take a base. Okay, what will this base do? This H is highly acidic, it will abstract this hydrogen, right? So how much we'll get now? N, so we get a salt. So this is a base, this is a base, this is an acid, reaction is taking place, so we get a salt. Now what happens when you treat this Rx? This is delta minus, this is delta plus. So what will happen? This N minus will attack on R and this X goes out. So we will get NR, and this is N-alkyl phthalimide. Okay, we get here N-alkyl phthalimide. Now what happens when you treat it with NaOH? Okay, this all gets disrupted and we get finally RNH2. Okay, RNH2 we get from here. Now here that you should remember, this Rx must be primary amines. Sorry, must be primary halides. Okay. No, sorry, one second. This RNH2 which is produced here, these are always primary amines. Okay, clear? Next, we'll do some questions now. In the preparation of amines, we have got 6 methods. Like, let us quickly revise once again. Reduction of nitro compounds. First one, what was the reagent for that? SnHCl, FeHCl or hydrogen and nickel. Then second one was ammonolysis. Third one was reduction of nitriles, RCN. For that we have LiAlH4 or H2 palladium or sodium amalgam in ethanol. Next, fourth one was reduction of nitro compounds. For that we need LiAlH4, right, lithium aluminium hydride. Then fifth one was Gabriel phthalimide synthesis. The sixth one was Hoffman bromamide, and for that we need Br2 in presence of NaOH or KOH. Clear? Fine. Now let us go to preparation of amines here. How do you prepare primary amines from nitro compounds? Give 2 methods. Okay. So this question has been asked many times, so it is an important question. How to prepare primary amines from nitro compounds? We can easily do it. We have 2 reagents, 2 methods means you can use any 2 reagents. One is your SnHCl, another you can use is your hydrogen palladium, right? So you can see here. Reduction, okay, so first of all let me write the reaction here. You can prepare by treating it with, so I will write like this, where I can write, yeah, 1A, okay, question number 1A, you can prepare primary amines by treating the nitro compounds with SnHCl or FeHCl, okay, this is one method. And second method you can write by treating it with H2 palladium. Okay, these are the 2 methods. Next question is, during the reduction of nitro compounds to amines, okay, scrap iron and hydrochloric acid is used. This one, scrap iron and hydrochloric acid is used or preferred. Give reason for that. So now this is a very important question here. This is also given in your NCERT book. You can see here, reduction with iron scrap and HCl is preferred because FeCl2 formed gets hydrolyzed to release hydrochloric acid again during the reaction. So when this one is happening, okay, Fe and HCl you are taking, from that we get FeCl2, okay, and this FeCl2 again gets hydrolyzed to give you HCl, okay, so which is required in this reaction, okay. So that is why does only a small amount of hydrochloric acid is required to initiate the reaction. So once you have to give first time HCl, and after that again and again in that reaction only HCl will be produced. So you do not have to add extra HCl later. Only one time you have to put, and once it is finished again it is produced. Once it is consumed again it is produced, right? So that is why we prefer this FeHCl. Clear this question? Next, what is ammonolysis? Explain with general equation. So ammonolysis is what? One second. So lysis always means breaking. Ammonolysis means breaking we using ammonia. So this is there. The process of breaking CX bond in haloalkanes by NH3 is called as ammonolysis. Now how can I write the example for this one? You have like, I'll take different color. Okay, so if you have, we'll use, okay, so if you have like CH3Cl and you are treating it with ammonia, okay, then what I'll get? CH3C NH4 plus, it will react with this one, so we'll get, NH3 plus and Cl minus, okay, and again if you treat it with NaOH, okay, we get here CH3 NH2. Clear? So that is your option answer for third question. Okay, this question was asked in March 2015. Now let us move towards the second question here. How many moles of alkyl halide, okay, is required for primary, secondary and tertiary amines to form quaternary ammonium salts? Okay, so now see here, for quaternary ammonium salts, okay, for quaternary ammonium salts you have like N is replaced with 4 groups, okay, 4 groups should be there, okay, 4 R groups should be there, then we call it as quaternary salt. Now if you have primary amine, okay, that means RNH2, right? If you have primary amine, then how many groups are required? You need 3 more, right, to make it quaternary. So for primary we will be requiring 3 groups. For secondary means you have already 2 R and you need 2 more R, right? So in that case you just need 2 group, and if you have tertiary, okay, tertiary group, then you already have 3 and you need 1 more, so that is 1 group. Okay, clear? So 1 R group will be required. This is done. How do you obtain primary amines from quaternary ammonium salt? Give equations. So just now we have discussed the primary amines, okay, the quaternary ammonium salt reacts with NaOH to give you primary amines, okay. So primary amines is obtained from quaternary salt by treating with strong base. So we can take an example like CH3Cl. If you treat it with NH3, we get here CH3, okay, this one will react on this one and this one will come out, so we will get NH3 plus and Cl minus, and once you treat this one with NaOH, okay, we get here CH3 NH2, okay, that is your primary amine. So option answer number B is done, okay. Next, question number 3. Write the chemical equations for the following reactions. Okay, reactions of ammonia with C2H5Cl. Okay, so first one, if I want to write reaction of A1. Okay, reactions of ammonia with C2H5Cl. So you have C2H5Cl plus ammonia. Okay, then what will happen? This one will react with this one and this one will go out. So we will get here C2H5 then NH2. Okay, so one of the hydrogen and chlorine will come out and NH2 and R will be forming. Okay, then ammonolysis of benzyl chloride and reaction of amine so formed with 2 molecules of CH3Cl. Okay, so if you see first one, ammonolysis of benzyl chloride, that means you have CH2Cl plus NH3. Okay, now if this one is there, what will happen? H and Cl will come out from here and I will get here, this one is there and here you have NH2. Okay, so N here, listen here. So what happens? What is happening? From this carbon you will attach NH2 and HCl will come out. Now after that again you are treating with 2 molecules of CH3, right? 2 molecules of CH3Cl means both the hydrogens will be replaced. So we will get here this one N and here we will get methyl group and here we will get methyl group. Okay, so that is your these 2 reactions. Next, name the final product formed when primary amine reacts with excess of alkyl halide. So when you react excess of alkyl halide, finally we get quaternary salt. Okay, quaternary salt is produced. So this is Next question, give a disadvantage of ammonolysis. Disadvantage is that it gives you a mixture of primary, secondary and tertiary amines, right? You can see here. So we'll get quaternary salt, it gives a mixture of primary, secondary and tertiary amines which is difficult to separate. Clear? Next, let us move towards question number 4. So you can see now we are in the preparation chapter. I told you there are 6 methods of preparation, right? The first one was your nitro compounds. We discussed questions from that. Then we discussed ammonolysis, some reactions questions. Now we are in the method of preparing from nitriles. Explain with an example. So primary amines can be prepared from nitriles by using 3 reagents: LiAlH4, sodium amalgam and ethanol, or hydrogen and nickel, right? You can write anything and write one example for that. So nitriles on reduction with LaH, or catalytic hydrogen with hydrogen and nickel, or with sodium AC2H5 can give you primary amines. So if you want to write an example for this one, option A example, sorry, question number A example will be nitriles, right? So I'll take CH3, C triple bond N, and if I treat it with, let me treat it with hydrogen and nickel, so I will get CH3, CH2 and NH2. Clear? Next, how do you prepare amines from amides? So here also for amides we have only one reagent, that is your lithium aluminium hydride. So you can write down by treating with lithium aluminium hydride and water. Again explain with an example. So if I have CH3, C triple, if we have CH3, C triple bond N, and if I have lithium aluminium hydride with water, okay, so that one will give me CH3, CH2 and NH2. Okay, sorry, this one has to be amide group. Okay, reaction of amide group. So we have, okay, clear? Now coming to question number 5. How would you prepare primary amine by Gabriel thalamide synthesis? Give equation. So I have already discussed you the mechanism, so I'll just show you once again here. So you can see first you need to take thalamide, react it with KOH, right? Then what will happen here? The salt formation will take place. Then you take one RX, then we get NR, and then finally you treat it with NaOH, hydrolysis takes place and we get RNH2. Clear? Next question is what are the advantages of Gabriel thalamide reaction? So advantage here is you can directly get primary amines. Like in ammonolysis you are getting a mixture of primary, secondary and tertiary. That this problem is not in Gabriel thalamide. You can directly get pure primary amines. Okay. Next, give reason aromatic primary amines cannot be prepared by Gabriel thalamide synthesis. Now see, I'll give you the mechanism, then it will be clear. Now suppose if I take an aromatic group here, right, and we know that this bond is very strong, right? Now what is the mechanism happening here? N is attacking R, X is going out, so we are getting NR here, right? But if it is an aromatic group, this one will not, this process cannot take place because this is what? sp2 carbon, there is resonance involved, this bond is very stable, nucleophile attack cannot take place, right? So that is why aromatic amines will not be formed within this mechanism. Okay, so that is the answer. You can see here question B. In this method secondary and amines are not formed as byproducts. And why it is not possible to synthesize aromatic amines? That is because aryl halides do not undergo nucleophilic substitution reaction with the anion formed by thalamide. So what is the anion formed? This is the anion formed by thalamide. So this haloarenes cannot undergo this nucleophilic reactions. Reason we all know, we have studied in the haloarenes chapter as well. Okay, let us move to the next question. So see which all preparation methods we have done questions. We did with NO2, we did ammonolysis also, we did with nitriles and your nitriles and amides, we did Gabriel thalamide. Last method Hoffman bromamide. We'll do some question from here. What is Hoffman bromamide reaction? Give an example. You see how important this question is, so many times it is asked. So you can write down whenever amides react with presence of X2 and NaOH, it produce amines with one carbon less. Okay, so that is Hoffman bromamide degradation. Amides on heating with Br2 and aqueous NaOH gives one primary amines. This reaction is called as your Hoffman bromamide degradation. Okay, I have written in short, you need to write the full answer. Clear? Next is name the product obtained when the following is heated with bromine and aqueous NaOH. Okay, you have to write the product name when the following is heated. So first one is what? Acetamide. Okay, so that means acetamide is CH3CONH2. Okay, this is acetamide, right? Now if you heat acetamide with bromine and aqueous KOH or NaOH, right? Bromine and aqueous KOH. So what will happen? This CO group will not be there and we will get CH3NH2. So what is the product here? Product here is CH3NH2, or we can call it methanamine. I'll change the color here, sorry. Okay. Now coming to the second one, you are having propanamide, means you are having CH3, CH2, CONH2. Okay, and you are treating with this one. So what will happen? Again this group will be not there, so we will get CH3, CH2, NH2, and here it is CH3, CH2 and NH2. Okay, so name the product. This is your ethanamine, this is methanamine. Okay, methanamine, okay, and you have here it is ethanamine. Next you have butanamide, and if you react with butanamide you will get 3 carbon, that is propanamine. Okay, and next we have benzamide. So if we have benzamide we will get like this. Okay, and this group will go and we will get aniline. Okay, and we will get here aniline. Clear? So this will be the product's name. Okay, next we'll go to question number 7, where we are now done with the methods of preparation. Now we are going to study about the basic physical properties, questions from physical properties. Very simple questions these are there. Aliphatic amines of lower masses are soluble in water. Whenever question comes about solubility, it is always due to hydrogen bonding, right? So next one, you can say due to hydrogen bonding. Next, the solubility of aliphatic primary amines decreases with the increase in molecular mass. So if the R group, okay, is very big, the hydrophobic part is very big, then it is difficult to form hydrogen bonding due to steric hindrance. So that is why the solubility decreases. So what is there? Due to the increase in the hydrophobic part. Next, boiling point of primary amines and secondary amines are higher than the non-polar compounds of molecular masses. Comparable molecular masses explained. Again, whenever boiling points comes, it is due to the intermolecular hydrogen bonding. Okay, when the molecules are tightly bound to each other, they cannot evaporate, they cannot go out, they cannot separate from each other easily. So you need to provide more energy in that case. Okay, next we have boiling point of tertiary amines are less than primary and secondary amines. Why? So tertiary amines do not form hydrogen bond because they do not have H to get hydrogen bond. That is why their boiling point is less, right? So due to the absence of intermolecular hydrogen bonding. Last one, among primary and secondary amines, which category of amines have higher boiling point and why? So primary amines have higher boiling point, okay, and why? Because primary amines can form more hydrogen bond. Why? Because they have more H. So if you see primary amines, you have 2H there, okay, and in secondary amines you have 1H, right, and here we have 2H. So 2H is there, so more hydrogen bonding will take place. Here 1H is there, less hydrogen bonding will take place. So more hydrogen bonding means more intermolecular force, means more energy is required to boil them. Okay, so I hope students you are enjoying the class, you are able to answer these questions. If you are able to understand, then please like the channel and comment your answers, give some response, so that I will feel, when I read that, I will feel motivated about this. Okay, fine. Let us go to now chemical reactions. Okay, chemical reactions of amines. So first one is basic nature. This is very, very important. Here you should remember two things. In gaseous medium, What is the order of basicity? 3 degree, 2 degree and 1 degree. Okay, but in aqueous medium we have two things, 2 degree, 1 degree and 3 degree for R equal to methyl group. Okay, and you have 2 degree, 3 degree and 1 degree for R equal to ethyl group. Clear? Basic nature. Then alkylation. What is alkylation? That means you are adding R group to the amine, that is your ammonolysis. Alkylation will take place. Next is acylation, adding of this group CH3CO. Okay, so when you add this one to we get amides product. Okay, I'll show you the reactions also. Carbylamine, then reaction with nitric acid, reactions with arine sulfonyl chloride and electrophilic substitution. Under that we have nitration, sulfonation and hydrogenation. Okay, halogenation, sorry. Let us see. So how many 7 reactions are there? What are there? First is basicity, alkylation, acylation, right? These 3 things you can remember: basicity, alkylation and acylation. Then you have, after that, these 3 reactions are used for you can remember testing primary, secondary and tertiary amines. Okay, so carbyl amine reaction, that is there, and your benzene sulfonyl chloride is there, reaction with nitrous acid is there. And 7th one is electrophilic substitution reaction. Under that we have 3 categories: nitration, halogenation and sulfonation. Okay, fine. Let us go to the next here. You can see this reaction. The first one, as I told you, was basicity, and after basicity we have alkylation, right? So to convert it into alkylation, you have to react with any halogen group. Okay, so what will happen? From H and X will come out and N will be replaced with, one of the hydrogen will be replaced with R. So this is your first one, that is alkylation. Okay, second one is acylation. So in acylation we get the product amide groups are formed. Okay, so now here what happens? To get this acylation, you have 3 reagents you can use. One is acyl chloride, another is anhydride and another is benzyl chloride. Okay, benzoyl chloride. Now see what happens here. This is nucleophile. Okay, this is delta minus, this is delta plus. So this one will attack here, this bond will come here and this bond will go out. So what is happening here? You get this COR is present. To this Rn means, what I can say is this Cl group is removed and this group is substituted there. So which Cl is going means one H will also go. So you have N here, R here and H here. Okay, this is your substituted amides. Now similarly this same reaction can also take with anhydrides. Okay, here what will happen? This is the lone pair, it will attack here, this bond will come and this bond will go out. So this whole part will be replaced with this RNH group. Okay, that is RNH group. Next we have the same thing if you do with benzoyl chloride. Okay, then it is called as benzoylation. Okay, here this name is not acylation, it is called as benzoylation. Okay, now again same thing, what will happen here? This Cl group will be removed and in place of that we have RNH group, right? RNH group is present. Clear? So this is done, alkylation, acylation. After alkylation and acylation, third one was the reaction with isocyanate, or you can say carbyl amine reaction. Okay, so in carbyl amine reaction what we have? CHCl3, KOH and heating. If you treat with this one, we get isocyanates, and these isocyanates have a foul smell. Okay, so and this is carbyl amine reaction is only for primary amines and it can be used as a test for primary amines. Okay, so done. First is basicity, done. Then we have done alkylation, acylation. Then we have discussed the reaction with carbyl amine reaction. Okay, then you have here reaction with nitrous acid. Okay, so this is the fourth one, reaction with nitrous acid. So here you should remember 2 things. If it is an aliphatic amine and if you are reacting with HNO2 and you get their alcohols as a product, okay, but if it is an aromatic amines like aniline and you treat it with nitrous acid, you get benzene diazonium chloride. Clear? So that is there. Next is your reaction with sulfonyl chloride. So this is very important. Aryl sulfonyl chloride. Okay, this particular reagent is also called as Hinsberg reagent. Okay, Hinsberg reagent. Now here what happens, this Hinsberg reagent and primary amine, if it is there, this HCl, this part will be removed, okay, and we get a compound like this. Okay, now this compound is having one acidic H, because of which this compound will be soluble in base or alkali. Okay, now if you take a secondary, so this is primary amine, if you take a secondary amine, what will happen? Again this Cl and H will go and you will get a compound like this where there is no acidic H, so this one is insoluble in alkali. Insoluble in alkali. Next one is your tertiary amine. So tertiary amine, you see there is no hydrogen to react with this chlorine, so that is why there is no reaction at all for tertiary amines. Okay, let us revise the reactions that we have studied till now. First is basicity, then is alkylation. For alkylation you need to treat the amine with Rx. Then is acylation. For acylation you can use acyl chlorides, anhydrides or benzoyl chlorides. Then fourth one was your carbyl amine reaction. Fifth one, reaction with nitrous acid. Here you should remember aliphatic amines will give you alcohols. Aromatic amines, that is aniline, will give you benzene diazonium chloride. Done. Next, after that, sulfonyl chloride. So this can be used as a test between primary, secondary and tertiary amines, right? Primary amines will be giving a compound which is soluble in alkali, secondary amines will give you a compound which is insoluble in alkali, and tertiary will not react at all. So next, coming to the sixth reaction, that is your electrophilic substitution reaction. This is very, very important. Now we told you an electrophilic substitution, we have three things: halogenation, nitration and sulfonation. So let us first talk about halogenation. Now see, this NH2 group is an electron donating group, so it is a highly activating group. It activates at the ortho and para position. So if you just treat with bromine water, okay, all these three positions will be occupied. Clear? Halogenation, the first point, that is if you just treat directly with bromine water, all the three positions will be occupied. Okay, now what we can do is, if I don't want all the positions, I want only one position or only the para position, there is something called as protection of this NH2 group. You can react this NH2 group with anhydride, okay, acetic anhydride, then we get NHCOCH3. After that, if you do bromine in presence of CH3COH, you will get only the primary para substituted product, and after that you just treat it with water, you will get NH2 back. Okay, so by treating with NHCO, by making this NHCOCH3, you are reducing the activity of the NH2 group, or you are reducing the what I can say, the electron donating nature of NHCOCH3. Okay, so that is why what happens. So in bromination, if you do directly bromine water, you will get all the three positions substituted. But if you want only at para position, first you need to protect or cap the NH2 group. For that you need to take acetic anhydride. Once you take that, okay, then you treat with bromine and acetic acid, then you will get only para position, and after that you can treat with H plus and OH minus to convert it back to NH2. Okay, halogenation over. Then you have nitration. Okay, for nitration also the same thing. If you just take direct nitration, you will get separate products, that is para product, meta product and ortho product. Now here the important thing is, NH2, as I told you, is an electron donating group. You should get ortho and para products, but we also get a significant amount of meta product. This question was there in the MCQ, today's MCQ, when we are discussing what happens when this HNO3 is present, right? This becomes NH3 plus and it is becoming now electron withdrawing group, and it directs the incoming NO2 group to the meta position. Okay, but if you want only para product, then the same thing you need to do. You need to first protect it and then you treat it with concentrated HNO3 and H2SO4, you will get only para product. After that you can, to remove this one, you can do hydrolysis, you will get NH2. Clear? This is done. Next is your sulfonation. So for sulfonation, concentrated H2SO4 you give, this is acid, this is acid. So what, sorry, this is base, this is acid, first a salt is formed here, okay. So we get here NH3 plus and HSO4 minus. After that there is some we can say rearrangement and we get SO3H, and after that there is a proton transfer and you get NH3 plus and SO3 minus. This is your final product for sulfonation, okay. Now we'll do questions from here. Okay, the first question is about basic nature, okay. Amines can act as a nucleophile or amines can behave as a Lewis base, give reason. So why can amines behave as a base? Because they have lone pair on nitrogen, right. So because of lone pair on the nitrogen. Next, aliphatic amines are stronger bases than ammonia. So if you see, aliphatic amines are like this, right, and these R group have plus I effect, so they donate electrons to this nitrogen, its electron density increases, so it can donate better, right. So that is why aliphatic amines are better bases than ammonia, that is due to the plus I effect of this alkyl group. Now what is the third question here? Aromatic amines are weaker bases than ammonia, give reason. So if you compare aromatic amines, okay, so what happens here? This lone pair of electrons is involved in resonance, okay. Now if this is involved in resonance, it is not available for donation, not available for donation, right. So that is why the basicity of aromatic amines decreases, that is lone pair on nitrogen is involved in resonance with the benzene ring. Next question, arrange primary, secondary and tertiary amines in the increasing order of their basicity in gaseous medium. So I told you for gaseous medium it is 3 degree, 2 degree and 1 degree, okay. Next, arrange the following in the decreasing order of basicity in the aqueous medium. So aqueous medium, R should be methyl group, in that case the order is 2 degree, 1 degree, 3 degree and then ammonia. This is a very important question. You must remember the order of basicity in the aqueous medium for methyl group and for ethyl group, okay. Next is question number 9. Why is aniline less basic than ammonia? Again you can answer here, because here the lone pair of nitrogen is involved in resonance. Next, write the basicity order of primary, secondary and tertiary amines according to the following thing, okay. So now if you see here, I'll write the first one, not this one, wait, okay. So option number B, question number B, with hydration effect, okay. Hydration effect is, the order is like this, 1 degree, 2 degree and 3 degree. Smaller is the amine, more is the hydration effect. Then steric effect, you know, less steric, again 1 degree, 2 degree and 3 degree. Now if you have plus I effect, according to plus I effect we have 3 degree, 2 degree and 1 degree, okay. That is there. This is done, this is done. Here you can write down lone pair of nitrogen is involved, right, in resonance, okay. Next, the basic strength of methyl amines in the aqueous medium is order of 213, whereas in ethyl group it is because of 231. Explain with reason. So why the order is changing in aqueous medium, also why it is different for methyl group and ethyl group. So in aqueous medium there are two factors which is playing the role, the hydration effect and the steric hindrance as well, right, and the inductive effect. So if you combine these all things, there is a different results we get. So you can see here, in methyl amines there is no much steric hindrance to hydrogen bonding in aqueous medium, right. Therefore the order of the basic strength for methyl group is 213. But ethyl amine or higher alkyl amines, there will be steric hindrance to hydrogen bonding. Therefore the change of nature of alkyl group from CH3 to C2H5 or high alkyl group results in the change of the order of basic strength to 231, okay. So because of the steric hindrance in hydrogen bonding, the order changes. In methyl group it is 213, in ethyl group it is 231, okay. Next is question number 10 here. Again we are still in basic nature. How does basic nature of the substituted aniline changes in the presence of electron releasing group? So if electron releasing groups are there, right, it will donate more electrons. So the nitrogen will have more electron density, so it can donate better, basic nature will increase. So here what will happen? It will increase. How does basic nature of the substituted aniline changes in presence of electron withdrawing group like NO2, SO3H, COH and X? Yes, electron withdrawing group, they will withdraw the electrons from the nitrogen, lone pair or the electron density on the nitrogen will decrease, so donation will be difficult, so basicity will also decrease. Arrange the following in the decreasing order of their basic strength. So you have C6H5, C2H5 and C2H5 2NH. Okay. So now if you see here we have 2 degree, right? Definitely that one will be more basic. Then you have 1 degree. Okay. So I'll write the formula of the compounds. 1 second. Yeah. So first it is C2H5NH2. C2H5 whole 2 NH2. Then you have C2H5NH2. Okay, and then you have C6H5NH2. Okay, clear? So that is the order for this one. Next is question number 11. Now we have come to the second alkylation, no much important questions. Ammonolysis we have already done. So we are now doing on the third reaction, that is acylation. Okay. So explain acylation of amines with an example. So here you can write down amines can react with acyl chlorides or acetic anhydrides to give you substituted amides. Okay. So you can see here. Okay. Primary and primary and secondary amines, both aliphatic and aromatic, react with acid chlorides or anhydrides and esters by nucleophilic substitution reaction. This reaction is known as acylation and the product obtained are N-substituted amides. Okay. Give an example. So we will write one example here. So I'll write here only. Suppose you have ammonia, right? CH3. Let me start from here. Okay. A example. Okay, so I'm writing suppose CH3 NH2 plus I want to react it with this acyl chloride CH3 COCl. What will happen? This will behave as a lone pair, it will attack here, right? So this Cl will be replaced, HCl will go and it will be replaced with this group. So I will get CH3 C double bond O, okay, NH CH3. Okay, so that is substituted amides. Next, what is the role of pyridine during acylation reaction of amines? So here we have to take in presence of pyridine. Okay, so what is the role of pyridine here? So what does pyridine do? You can see here. See, the reaction is carried out in the presence of a base stronger than the amine like pyridine, which removes the HCl so formed and shifts the equilibrium to the right side. Now see, what happens here in the byproduct we have an acid. So what I said, this chlorine and one hydrogen from here will come out to give you HCl, right? Now this HCl can reverse back the reaction. Okay, so to prevent that we use some pyridine, which is a very strong base, and it will remove this HCl and reaction will proceed in the forward direction. Okay, next question, tertiary amines cannot be acylated. Why? Because of, so we have next slide, we'll go. Tertiary amines cannot be acylated because they do not have this H in the tertiary amine. So what is the general equation? If you see, we have R N H2, okay, and here we have this one, right? Now this HCl is removed, right? So you need to have a one H in this amine group, but tertiary amines do not have any hydrogen, so that is why they cannot undergo acylation. Clear? Next, what is benzoylation? Give an example. So reaction of benzoyl chloride with the amines to form N-substituted benzamide. Example you can give very simple. We can take aniline here, okay, aniline, and if you are reacting it with CH3 COCl, so from here HNCl will be removed, right? So I will get here NHCOCH3. Okay, so that is your benzoylation. Okay, next is question number 12. What is carbylamine reaction? Carbylamine test. So that is the reaction of primary amines with CHCl3 and KOH to give you isocyanate, which have a foul smell, right? So you can see here aliphatic and aromatic primary amines on heating with chloroform and ethanolic potassium hydroxide, okay, form isocyanates or carbylamine, which are foul smelling substances. It is used as a test for primary amines. Reaction RNH2 plus CHCl3 KOH will give you RNC plus KCl plus water. Okay, next question number 13. So now we have discussed basicity, we discussed alkylation, we have not discussed, we discussed acylation, third reaction, then we discussed reaction with your carbylamine test. Okay, next fifth one is your reaction with HNO2. Here you remember alcohols, primary amines will give you alcohols and aromatic amines or aniline will give you benzene diazonium chloride. Okay, so how does aliphatic amines react with nitrous acid? They react to give you alcohol, right? So react to give you alcohols. Next, name the gas liberated when aliphatic primary amine react with nitrous acid. N2 gas is released here. So I can write the reaction for you. For example, I have let me use another ink. Okay, so for example, if you have CH3NH2 and if you are treating with HNO2, that is nitrous acid, you will get CH3OH plus N2 gas is produced. Okay, so that is why we say that N2 gas is produced here. Next, name the product formed when methylamine reacts with nitrous acid. So you will get the alcohol of it, that is your methanol you will get. What is diazotization, or how does aromatic primary amine reacts with nitrous acid? So aromatic primary amines react with nitrous acid at 0 to 5 degrees Celsius. Okay, this temperature is very important to give you benzene diazonium chloride. What is the reaction here? If I want to write this reaction, so it is you have aniline NH2 and you treat it with HNO2. Okay, and you get here N2 plus and Cl minus, which is your benzene diazonium chloride. Okay, next you have what temperature should be maintained for diazotization. It is 0 to 5 degree or 273 to 278 Kelvin. Okay, next is question number 14. So now we have gone to the fifth reaction, that is your reaction with aryl sulfonyl chlorides. What is Hinsberg reagent? How do you distinguish between primary, secondary and tertiary amines by using Hinsberg reagent? So first I will show you this answer. So benzene sulfonyl chloride is known as your Hinsberg reagent, reacts with primary, secondary amines to form sulfonamides. Okay, this is important. Now how does primary amines will react? See, primary amines react with Hinsberg reagent to form N-alkyl benzene sulfonamide, which is soluble in alkali due to the presence of acidic H on nitrogen atom. We have already seen this reaction. Here what happens? This is your Hinsberg reagent, this is primary amine, here this HCl is removed, right? So this is now this part, this is removed and we get this part here, and this has an acidic hydrogen because of which it is soluble in alkali. Okay, next one, secondary amines react with Hinsberg reagent to form NN-dialkene benzene sulfonamide, which is insoluble in alkali due to the absence of hydrogen on the nitrogen atom. So you can see here again, here we have taken a secondary amine and here we have taken HCl. So this one is there, and now this one is your NN-dialkyl benzene sulfonamide. Now this doesn't have acidic hydrogen, so this is insoluble in alkali. Okay. Now what happens here? Tertiary amines doesn't have any hydrogen, so it does not react at all. Okay, so that is your first question. Next, give reason why benzene sulfonamides formed from primary amines are soluble in alkali. Why is it soluble? Because of the presence of what? Acidic hydrogen, right? Because acidic hydrogen is attached to N. Now sulfonamide formed from secondary amines is insoluble because there is no S or no acidic H on the nitrogen atom. Tertiary amines do not react with Hinsberg reagent because of absence of hydrogen on the nitrogen of tertiary amines. Okay. Next, let us go to question number 15. So that is your substitution reaction. So again, let me revise what all reactions we have studied: basicity, alkylation, acylation, carbyl amine reaction. Then you have sulfonyl chloride, okay, reaction with nitrous acid, and last 7th one is your electrophilic substitution reaction. Okay, how does aniline reacts with bromine water? So if you directly put bromine water, all the groups will be substituted. You will get 2,4,6 tribromoaniline, right? So what will be the product here? We can write here, aniline reacts with bromine water to form white precipitate of 2,4,6 tribromoaniline. Name the product formed when aniline reacts with bromine water, 2,4,6 tribromoaniline. Next, how do you convert aniline into parabromoaniline, or identify the product XYZ in the following conversion? Okay, so both the questions will have the same answer. How will you convert aniline to parabromoaniline? Okay, so now if you first take aniline and you want only para product, then first you need to acyl it. For acylation, what you can use? You can use acetic anhydride, right? CH3CO whole 2O. Once you use this one, you will get acylated, you will get this one, NHCOCH3. Okay. Now if you take bromine and CH3COH, what will happen? Bromine will be produced at the para product. Okay. So next one I can write, I'll write here only. So Y will be here, bromine will be added. Okay, and once you do H3O plus, this one will be again converted to NH2 group. Okay, so I will write once again those students who did not understand this one. Okay, let me write it again. Okay, for first of all we have aniline. Okay, we are treating this with we are doing acylation. Okay, one second. Yeah, you are doing acylation. Okay, now if you do acylation, you will get NHCOCH3. Next, you are doing bromine in ethanol, or you can use acetic acid. Sorry, not ethanol, you have to use acetic acid. Okay, so I am just writing bromine with acetic acid. So that is CH3COOH. So that will give you NHCOCH3 and bromine. Okay, now if you do hydrolysis, okay, you will get here NH2 with bromine. Clear? So now what is X, Y, Z here? So the X is your this one, acylated one, Y is the bromine one, and Z is this one. Clear? Got it? So next is question number 16. Identify the product XYZ in the reaction. Okay, it's very similar to this one. So 16A, if I write, okay, I'll write here 16A. First one will be what? Acylation has taken place. So I will get here NHCOCH3. Okay. Next you are doing concentrated HNO3 and H2SO4 will add nitro group at the para position. So what I'll get here? I will get NHCOCH3 and NO2 group. Okay. Now what will happen? If you do hydrolysis, this one will go and the product formed here will be NH2 and NO2. Okay. Clear? Next, coming to B, nitration of aniline gives meta product also. This we have discussed again. So when aniline is there, okay, you can see, and if you are doing HNO3, that aniline gets converted to anilium ion, which is an electron withdrawing group. Okay, so that is why we get meta product. So you can see here in the strongly acidic medium, this is due to the presence of concentrated nitric acid. Aniline is protonated to form the anilium ion. So that NH3 plus is formed, which is meta directing. Okay. Next, question number C. Give reason aniline cannot be nitrated directly. You cannot directly nitrate aniline. What is the reason for that? So direct nitration of aniline is stary oxidation products in addition to the nitro derivative. Okay, so because it is a very strong oxidizing agent, you get some extra oxidized products also, which is not required. So that is why it is not very wise to do nitration directly on aniline. Clear? Okay, next question number 17 on the same electrophilic substitution. Friedel-Crafts reaction does not undergo, aniline does not undergo Friedel-Crafts reaction or acylation. Why? So this one again, give the self-explanatory equation for sulfonation of aniline. Okay, so first talking about Friedel-Crafts reaction. So if you remember, for Friedel-Crafts reaction, what is the reagent? You need CH3Cl with AlCl3, right? This AlCl3 is a Lewis acid, and in aniline we have this NH2 group, right? And this NH2 group is basic in nature, right? So this base and this acid will react with each other. Okay, that is what happens. So you can see here, aniline does not undergo Friedel-Crafts reaction due to the salt formation with aluminium chloride, the Lewis acid, which is used as a catalyst. Okay, due to this, the nitrogen of aniline, acquires a positive charge and hence act as a strong deactivating group for further reaction. Okay, it forms NH2, it forms AlCl4. Okay, so here a salt is formed and this one is behaving now as a strong electron withdrawing group. Clear? Next, sulfonation. We have already written this reaction with NH2. We'll first get this one, then it will have a rearrangement, and then we get this type of compound. Okay. Okay. Next, we'll go to benzene diazonium chloride. Some reactions of that let us see here. So, benzene diazonium chloride chemical reactions are of two types, where reactions involving the displacement of N2+. What is benzene diazonium chloride? All of you remember the structure of benzene diazonium chloride. It is N2+ and Cl-. So there are certain reactions where this N2+ is removed and replaced with different other ions or atoms. And another type of reactions is their coupling reaction. Okay, so what are the replacement? You can see replacement by Cl- or Cn-, replacement of I-, replacement of F- by H, replacement by OH, and replacement by NO2 group. Okay, let us see this quickly, these reactions. So how many replacement we have? 6, right? Cl-, F-, I-, you can remember. Then you have OH, H, okay, OH, H and NO2. Okay, Cl, F-, I-, OH, H and NO2. So let us see the first one. So this is your benzene diazonium chloride. If you treat it with CuCl2 or HCl, or CuBr2 or HBr, or CuCN and KCN, you get ArCl, ArBr and ArCl. These all reactions are called as Sandmeyer reaction. Okay. If you want chlorine or bromine, there is another method also where you just take Cu with HCl, Cu and HBr. You do not take salt of copper, you just take copper powder. But here you take salts of copper. Okay. If you are taking only copper powder, then we call it as a Gattermann reaction. Clear? So replacement by chlorine, bromine or Cn-, we have two methods. Okay. Next, that is the first part. Then is your replacement with I-, for that you just need to treat with Ki. Then for replacement with F-, you just need to treat it with HbF4. Okay. So you get here what? This is H+, this is BF4-, and then here N2+ will be there, BF4- will come. Then if you heat it, we get ArF, N2 and BF3 is formed. Okay. Next is to replace it with hydrogen. Okay, for replacing it with hydrogen, you have two methods. One is you can just treat it with ethyl alcohol, or you can treat it with H3PO2. Ethyl alcohol or H3PO2. Okay. Next, fifth one, to replace it with OH, you have to treat it with water. Sixth one, to replace it with nitro group, first you need to treat it with N2+ and BF4, HbF4. Okay. After that, NaNO2 and copper. NaNO2 and copper, that will give you nitro group. Clear? So let us revise these reactions once again. For Cl- and Cn-, here you have two options, right? One is your Sandmeyer reaction and another is your Gattermann reaction. For Sandmeyer reaction, you can use CuCl2HCl or CuBr2HBr, and for Gatterman reaction you will get CuHCl or CuHBr. Okay. For I minus, you can replace it by treating it with Ki. For F minus, you need HbF4, and after that you need to heat it. For replacement by H, again you have two methods. One is your H3PO2 and water, and another is your ethyl alcohol. For replacement with OH, you need water group. Okay. For replacement by NO2, you need for NO2, right? What was there? First you have to treat it with HbF4. Okay. Then whatever the product formed with Cu and NaNO2. Okay, that is there. So next is your coupling reaction. So coupling reaction, you have to remember, this benzene diazonium chloride are treated with phenol and aniline. So in that case what happens? This group is removed. Okay, and we get this type of product, and these products are called as azodies. Okay, and this para-hydroxy azobenzene is orange in color, and para-amino azobenzene is yellow in color. So color also you can remember. Next we will do some questions from this part. So what is Sandmeyer reaction? Give equation to convert benzene diazonium chloride to chlorobenzene by Sandmeyer reaction. So what is Sandmeyer reaction? Let us see. The chlorine minus, bromine minus and CN minus nucleophiles can easily be introduced, okay, in the benzene by treating diazonium salt solution with halogen acid and copper salts. This reaction is called as Sandmeyer reaction. You need to write the reaction and show that. So if you have taken benzene diazonium chloride N2 plus and Cl minus, you need to treat it what? With copper salt, right? Cu2Cl2 in presence of HCl to give you chlorobenzene. Okay. Explain Gatterman-Koch reaction. Next one, same thing, chlorine. So here in Gatterman-Koch we do not have CN group, okay, can be easily introduced to the benzene by treating diazonium salt solution with halogen acid and copper powder. This is called Gatterman-Koch reaction. Okay, if I want to write an example here, you can write like this. Once again, student, let me write down, then I will be aside. You can see, you can have N2 plus Cl minus with what? I want copper and HCl. Okay, so I will get here chlorobenzene. Okay. Next, how do you convert benzene diazonium chloride into aryl fluorobenzene? Give equation. So, okay, one second. Okay, so if I want to convert this one by treating it with HbF4. Okay, so if I want to write the equation, what will be the equation for C? It will be benzene diazonium chloride, okay, with HbF4, okay, and that one will give me N2 plus and BF4 minus, and then here what will happen? Here we will get fluorobenzene, okay, plus you will get BF3 plus N2 gas. Okay, this is done. Next, how do you convert benzene diazonium chloride into iodobenzene? So that is by treating it with Ki. Okay, simple reaction. You can write down the reaction here. Next, question number 19. We'll go to again chemical reactions of benzene diazonium chloride. Okay. Yeah. How do you convert benzene diazonium chloride into nitrobenzene? So for that, what you have to do? First is you need to treat it with HbF4, right? You have taken N2 plus and Cl minus, treat it with HbF4, and then you have here N2 plus and BF4 minus, and after that if you treat it with copper and NaNO2, okay, this one will give you what? This one will give you NO2 group. Okay. Next, explain the replacement of diazo group from benzene diazonium chloride by hydroxyl group. Okay, so if I want to get this one, I want hydroxyl group. Okay, so you have, this is option, this is B, this is C. So if you have N2 plus and Cl minus and you want to replace it with hydroxyl group, that is OH, okay, this one will be done in presence of water. Okay. Next is C, give the preparation of benzene from benzene diazonium chloride. So if I want to prepare benzene from benzene diazonium chloride, so okay, I want benzene here. Okay, so for benzene you can use either ethyl alcohol, or you can use ethyl alcohol, or one more was there, that is H3PO2, right, with water. Clear? Next E, what is there? Sorry, this is A. Okay, this is A. One second, here's some error I did with the numbering. Okay, so this is A, this is B, this is C. Let us see next D question. Arene diazonium ion is more stable than alkyl diazonium, give reason. So that is because of resonance. Okay, so where there is resonance, so if you can see here, it is like this, right? You have N triple bond N. So here there is resonance, because of which arene diazonium ions are more stable. Okay. Next, what is coupling reaction? So you can write down benzene diazonium chloride, okay, reacts with phenol or aniline to give azo dyes. This is called as coupling reaction. Now example, you can write down with phenol it gives you para hydroxy azobenzene, orange color, and with aniline it gives you para amino azobenzene, yellow color. Clear? Okay, so now let us do little revision about the nomenclature. Okay, so nomenclature, what is there? So for example, for primary secondary amines, if you have primary amines, then very simple, there are 2 carbons, so it is ethanamine. If there is 3 carbons, it is propanamine. Now here you can see, here you have 1, 2, 3, right? So you can make it as propane 2-amine on the second position. Now here this is your secondary amines, right? So in secondary amines the name is written like N-methyl and ethyl. Okay, so you have one N-methyl, N-ethyl. Okay, or when it is secondary amine you have to write one as N. Okay, like this. See, N-methyl, N-methyl, rest is ethanamine. Similarly, if you see this is tertiary, so you have to write 2 times N dimethyl methanamine. Okay, this is tertiary. Now here if I want to see, this is also tertiary, right? 2 ethyl groups are there. So what I can do, N diethyl 1, 2, 3, 4 butanamine. Okay, that is N diethyl butanamine. Next, if you see here, alkyl group is present 1, 2, 3, right? So we can write it as prop 2-en amine. Okay, prop 2-en 1-amine. Okay. Next, if you see, you have 2 amine groups, like the whole CH2 ring is there, and at the 2 end you have 2 NH2 group, then hexane 1,6-diamine. Okay. Next, if you see aromatic amines, so this is your aniline, or you can call it benzenamine. Here you can call it as 2-methyl aniline, then here you have 4-bromo aniline, and then here you can have N dimethyl benzenamine. Okay. Now coming to the most important topics that you should revise from this chapter. Under name reactions you have Sandmeyer reaction, Gattermann reaction, Gabriel thalamide, Hoffman bromamide, carbyl amine, then carbyl amine I have repeated. So these all things are from the different chapters. Sorry, this one you can eliminate. So these all name reactions are there. Then what on other topics you should focus? You should focus on nomenclature, basicity and coupling reactions. Okay, these are the most important topics that you need to do from this particular chapter. Next, coming to this week's schedule. So already we are in week 2. So today was Thursday, right, and we had done amines, and next class Friday will be there, that is on 29th physics. You will have moving charges and magnetism, and then Saturday, you know, that is double dhamaka day, you have bio and maths. So in bio, ma'am will be teaching you sexual reproduction in flowering plants, and in maths you will be having continuity and differentiability 1. Okay, and then Sunday again there is continuity and differentiability, only maths is there. You will have part 2 of this chapter. Okay, so okay, okay. So that's all, students. So we are done with this chapter of amines, and I can assure you, if you practice these 30 questions that I have given you, or these 20 questions that I have given you, not even a single 5-marker question, you will lose mark. Okay, so make sure that you practice this question properly, write down them, revise them, and complete this chapter today itself. Okay, so all the best, and if you have any doubt in any question, please comment down. I'll definitely address it. And what else what other help you want from us, that also you can let us know. We'll definitely make video for you all. And I hope this session was helpful and you are liking this Brahmastra series. So this is going to be a one-shot video. If you have done these all questions, then no need to look at book, no need to look at any other things. You can directly go and attempt the papers. You will be able to solve the questions. I can guarantee you that. Okay, so thank you students. That's all in this class. See you soon in the next episode.